All right, guys, section 6 of chapter 5, graph inequalities in two variables. This will be the last one for the chapter. So previously you graphed linear equations. Now we're going to graph linear inequalities on the coordinate plane and solve inequalities by graphing. So some new vocab we're going to run into is boundary, half planes. Now, I'm not talking about cutting an airplane in half or anything like that. Closed half plane and open half plane. We'll explain what those mean. So the graph of a linear inequality is the set of points that represent all of the possible solutions of that inequality. An equation defines a boundary which divides the coordinate plane into two half planes. So when you have an inequality in two variables, you have an x and y, so we're graphing something on the coordinate plane. The equation that you get from that makes a line, when you graph that line, that creates a boundary, which cuts the coordinate plane in two halves, a half plane to the right of it, and a half plane to the left of it, or you can think of it as half plane above it and a half plane below it, okay? So the boundary may or may not be included in the solution. So when it's an included, the solution is a closed half plane, and you put a solid line, just like on a number line. When the solution is, when the boundary is included, like on a number line, if like say it was x is less than or equal to 3, you would fill in the circle and shade to the left. All right, but if it was x is greater than 4, you would put an open circle and shade above it. So similarly, when we do it with linear inequalities, you have the line that represents the boundary. That's kind of like the point where you have the open or closed circle on the number line. And the way you do an open or closed line is a closed line, you just draw a solid line, and that indicates that the boundary is part of the solution set. If it's not, like you know how you did an open circle? Well, you can't just do an open line because there wouldn't be a line. You put a dashed line, okay, or a dotted line. Think of it like that. So the first step in graphing linear inequalities is graph the boundary. So you take the linear inequality, solve it for y, and then make it an equation, just like substitute an equal sign in there, and graph that line. If it's a or equal to inequality, like a less than or equal to, greater than or equal to, you draw the line as a solid line. Or you use the dashed line if it's strictly less than or strictly greater than. Then you test a point on either side of on one side of the boundary to determine which side you should shade. Okay, just like remember on the number line you had to shade one side of the boundary point. Well, here you have to shade one side of the entire boundary line. All right, and how you figure that out is you just pick a point on one side, test it in the inequality, and if it works, the side that you got the point from, you shade that side. If it doesn't work, that means that side of the plane doesn't work, so you shade the other side. All right, we'll go through an example. I know it's not kind of easy to understand just explaining it. So let's graph this one. First, solve the inequality for y in terms of x. In other words, get y by itself. So we're going to subtract 3x from both sides. So we did minus 3x here, minus 3x on that side. Okay, and then you have negative y is less than negative 3x plus 2. We have to divide everything by a negative to get the y completely by itself. And remember, when you multiply or divide by a negative in an inequality, you reverse the direction of the inequality. So it's y is greater than 3x minus 2. So select the test point, 0, 0. And if I take the original inequality and substitute 0, 0 in there, I end up with a statement that is true, because 3 times 0 minus 0 is 0, and 0 is less than 2. That means that 0, 0 is a solution to this inequality. So whatever side of this line, when I graph it, includes 0, 0, you shade that side. All right? So that's step 3. So here's what we did. We have y is greater than 3x minus 2. I graph the line y equals 3x minus 2. So I just go down 2, graph your y-intercept, and then use your slope, which is 3. So that's up 3 over 1 to get another point, and then connect them with a dashed line, go the whole way through. Okay, that's how you know where the boundary is. And it's a dashed line because it's strictly less than or strictly greater than situation. Then I picked a point 0, 0. Now you always pick the origin because it's easy to substitute 0 into stuff. Okay? The only time you don't pick the origin is if the boundary line actually goes through the origin. Then I'd pick like 1, 1. Okay? I substituted 0, 0 into the original inequality. You always want to substitute the point back into the original inequality. If it works, you shade that side. If it doesn't work, you shade the other side. All right, so let's try these ones. Go ahead and pause the video. All right, we're back. So 1a is already solved for y. So I want to graph the line y equals 1/2 x plus 3. So I'd go up 3, put a point, and then take my slope, go up 1 over 2, up 1 over 2. Then I can go down 1, back 2, down 1, back 2 to get a couple extra points. Now, since the inequality is strictly greater than, I'm going to do a dashed line like that. Now I'm going to test the point 0, 0 into the original inequality. So 0 is greater than 1/2 times 0 plus 3. So that would simplify to 0 is greater than 3. That's false. So I tested the point at the origin. It did not work, so I shade the other side of the line up there. Okay? So 1b is x minus 1 is greater than y. I'm just going to write that the other way. So y is less than x minus 1 to make it easier. Now, I'm going to graph the line y equals x minus 1. So go down 1, graph your y-intercept, and then the slope is understood to be a 1 in front of there, so it's up 1 over 1. And you just keep plotting points. Now, since it's strictly greater than, you have to do a dashed line like this. Then I'm going to test the origin in the original inequality. So 0 minus 1 is greater than 0. Well, that would simplify to negative 1 is greater than 0, which is false. So since the origin is there, I shade the other side because the origin doesn't work. So shade that side. Okay? So I hope that was helpful to you there. Now, let's talk about when you have the situation less than or equal to or greater than or equal to. Let's graph x plus 5y is less than or equal to 10. Again, you want to solve for y in terms of x. In other words, get y by itself. So subtract x from both sides. You get 5y is less than or equal to negative x plus 10. Then divide both sides by 5. Now, when you have negative x plus 10 and you divide both things by 5, there's understood to be a 1 in front of that x like that. So you can see that this is negative 1/5. And it's helpful to think of it like that, and 10 over 5 gives you 2, because negative 1/5 would end up being your slope, and that tells you your rise over run. Okay, so you graph the equal to part. So you would have a y-intercept of 2 and a slope of negative 1/5. And then you substitute a point. They use the point 3, 3. You could have, I would have picked 0, 0 because it works a lot more simply. But you can really use any point as long as it's not on the line. All right, so they took the original inequality, substituted 3, 3 in. They got 18 is less than 10, which is false, so that means the other side is the solution. So here's the line, y equals negative 1/5 x plus 2. Notice they put it in as a solid line because it's or equal to. They tested the point 3, 3. It did not work, so they shaded the other side of the line. All right, so here's 2 for you to try. Go ahead and pause the video. All right, we're back. So 2a, got to take and subtract x from both sides. And you'd have negative y is less than or equal to negative x plus 3. Divide everything by negative 1. So you have y is greater than or equal to, remember we divided by a negative, so we got to flip the inequality symbol, 1x minus 3. So you graph the or equal to part, y equals 1x plus or minus 3. So go down 3, 1, 2, 3, put a point, and then the slope is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And then you put a solid line because it's or equal to. Then I test the point 0, 0 in the original inequality. So I have 0 minus 0 is less than or equal to 3. Well, that simplifies. 0 is less than or equal to 3, which is true. So since the origin is there, above the line, I shade everything on that side of the line that contains the origin. Okay? Now, 2b, I'm going to break my rule of solving it for y. and I'm going to graph using intercepts. 2x plus 3y equals 18. Now remember, the intercepts is you put 0 in for x or y and then solve for y or x. So if I put 0 in for x, this part goes away and I would have 3y equals 18. Divide both sides by 3 and y equals 6. So that means the intercept, the y-intercept is 0, 6. So 1, 2, 3, 4, 5. That would be up there. And then substitute 0 in for y, and I would have 2x equals 18. So divide by 2, and you'd have x equals 9. So actually what I'm going to do, because those don't fit on the coordinate plane as I have them, I'm going to say each tick mark is worth 2 on the x-axis and the y-axis. So if I plot 0, 6, that would be right here. And if I do x equals 9, so you'd have 2, 4, 6, 8. This would be 10, so 9 would be right about here. Put a point. Connect those with a solid line. Okay. Now if I test 0, 0 in the inequality, I'd have 0 plus 0, is greater than or equal to 18, which is false, so the origin didn't work, so you shade the other side up there. Pretty cool, huh? All right, I hope that part was helpful to you. All right, guys, that's it for this video. Stay tuned for the second half.